everyone, in this video we are going to discuss the solution for sort array by parity. So let's see how we can solve this problem. Okay, so first thing we need to know is what is given in the question. So in the question we have been given an array of integers that are positive integers. Okay, and what we need to do is we need to sort this array in such a way that all the even numbers come first and all the odd numbers come after them, and we are asked to preserve the order of even elements also. Okay, now before we try to solve the question, I would like to ask you a question here. Have you solved the question sort 0 1 in L1's time and space complexity module, or even done the quick sort, especially the partition algorithm for the quick sort? If you have done that, then this question is very easy because we are doing the same thing here. And if you haven't done that question, I will suggest you to go back and do that question, and I'm pretty sure that you will be able to solve this question very easily. Okay, so you can try to do that, or I'm doing the question also. So first thing, what we are going to do is we are going to assume something. We are going to assume that this is my array and I have solved some part of it. Okay, this is segment 1, segment 2 and segment 3. So what this segment 1, I have solved this uh, question. Let's suppose that I am solving this question and I am in the middle of solving the question. So I have been told that all the even element should be followed by odd element. Okay, so I am trying to do that, and this segment 1, what I'm doing is I'm putting even elements. Okay, and in segment 2 I'm putting all the odd elements. This is my array and I have made some segments of this array in which first part has even numbers and second part has odd numbers. All right, and in third part we have unsolved elements, meaning that we haven't checked for any of these numbers right now, and we have checked for two kind of number till now. First is even numbers, second is odd numbers. Okay, now we are doing partition sort of thing here. This is a partition. Okay, so let's put some pointer on that partition. Let's call it J and let's call it I. Okay, now what J is going to represent? J is going to represent the first odd number from the odd segment. See, this is my odd segment now, in which we have all the odd numbers. This is J is going to represent the first odd number in this odd segment, second segment. Okay, and what this I is representing? I is representing the first unsolved element. And what do I mean by that? I mean that this ith element is going to be checked whether it is even or odd, and according to its value, if it is even then it will go to this segment, and if it is odd then this will go to odd segment or second segment, I should say. Okay, so we need to take decision for nums I because my array is called nums. All right, now there are two ways this can go. First, that nums I or the ith element is the odd number, or it is a even number. Now let's suppose that this I element is currently odd. Okay, so in which segment this ith element should go? this element should go in the odd segment or the second segment, right? So this segment is going to get extended, and this segment now will include this odd number. All right, and I will go forward. Okay, now I has checked for this element. Now I has moved forward. Now I suddenly found a even number here. Okay, so I have found a even number, and now I need to include it into this even segment. So what I'm going to do is, see very carefully. Okay, what I'm going to do is I'm going to swap this ith element with the jth element. Now remember what I said about j. J was my first odd number, meaning that this is my first odd number, and before this jth element, all the numbers that are present are even numbers. So if I will do swap of I and j, what is going to happen? This element will become even number, and this will become my odd number here. This will be odd. Okay, and my segment 1 will move on to this segment part, and my segment 2 will shift from this place where j was originally to one step further, and now j will move forward. Now j is going to represent the first odd number again. Here I have odd number, and j has moved forward. And what about I has ith element, decision for ith element has been done, so I will also move forward. So here's my I. Now another element is going to be checked if it is even or odd. So that's how we are going to solve our problem. If we are going to divide this array into three segments: even segment, odd segment, and unsolved segment. And what we are going to do, put pointers on these segments. J is going to represent the first odd number, I is going to represent first on unsolved number, and whenever I encounter a odd number, I will just increase I. Okay, that's what we did in this part. And if I encounter a even number, what I'm going to do, I'm going to swap I and jth element, and I will increase the j pointer, and I will increase my I pointer also. Now let's do a dry run for this logic. Okay, let's take this output also, so that we can later check if we have solved it right or not. Okay, now this is my array, and let's place our I and j pointer. This is my I pointer, and this is my j pointer. Okay, this is 3, and this was n. Okay, now what I have encountered, I have encountered 9, which is odd. So I will just move my I. Now I is pointing at 3. Okay, now 3 is the odd number, so I will move forward. Now I has encountered even number. So first thing what we are going to do, we are going to swap ith element and jth element. Ith element is 8, jth element is 9. Okay, so let's swap them. This is my 8, this is my 9, right? And j is going to move forward and I is also going to move forward. Now I have encountered 7. Now 7 is a odd number, so I will move forward. Now I have encountered 6. 6 is the even number. So what we are going to do? We are going to swap ith element and jth element. So let's swap them. 6 and 3. Okay. Now I will move forward. J will also move forward. Now I have encountered 2. 2 is the even number. So again we are going to swap them. 2 and 9. Okay. I is going to move forward. J is also going to move forward. Now I has encountered 3. 3 is the odd number. So I will move forward. Now I is pointing at nothing, which means that our array is completely sorted now. And we also have one pointer which is representing the start of the odd segment of array. Okay, now you can clearly see that the order of our even numbers are also preserved. 8 come at first place, 6 comes as second place, and 2 come at third place in this. And here you can see first, second, and third. The relative order of even numbers didn't change, but the relative order of odd numbers changed. And you can clearly match our output that we have generated just now with our actual output, which is this 8627 8627 393 393. Okay, so that was the approach part. Now we just need to implement it. So let's try to implement it. Okay, so we need just 2 pointers. Okay, so first pointer I equal to 0, j equal to 0, and we need a while loop now in which I is less than nums dot length, because I was moving till the end of the array. Okay, now look carefully that I was increasing always, even if it is odd or if it is even. Okay, and if we encountered an even number, we weren't doing much, we were just increasing our I. But if we were encountering even number, so we were doing 2 steps more. We were swapping I and j element and increasing our j. So we are going to write this here. If nums I is divisible by 2, which means that is even number, then I need to swap them. Swap what? Ith and jth element. So let's swap them. Int temp equal to nums I equals to nums j, nums j equals temp and j plus plus. And as discussed, I is always moving forward. So that's it. That was the code. So let's run it. So we got successful submission for our sample test case. Let's submit for all test cases. Alright then. We got successful submission, which means our code is completely correct. Okay, now let's talk about its time complexity. Okay, for our approach, what we are doing, we were checking each time for ith element. First we check for this, then this, then this. So in all cases, what we were doing, we were doing some operation n number of times. So our time complexity is nothing but O big O of n. Okay. And what about our space complexity? Space complexity is nothing but O of 1. Constant space complexity, because we haven't used anything extra here. We just used 2 pointers and nothing else. Okay. We haven't used any extra additional space. So that's all for the solution of this question, and I hope that you have understood it well. And if you haven't, I will recommend you to see its dry run once again, and I'm sure you will be able to understand it. So that's all for this video, and I will see you in the next one. Okay, so goodbye.